All right. So same idea as what we did on Friday, where we had just said long and synthetic division. It was a reminder of what it is and how to do it. Same thing today. Complex numbers, when we look at imaginary and complex numbers, today is just going to be a reminder of here's what they are and here's how you work with them. How do I add complex numbers? How do I multiply them? Just kind of operations with complex numbers. Then, like I had said, we'll put that all together in the next few days and kind of add it into what we were doing last week. But for now, we're just going to be using those complex numbers. Okay? So, let's start at the beginning with the definition of imaginary number. Okay? You got an imaginary unit called I, and I is defined as the square root of -1. Okay? That's where we start. So we've talked before that when you're doing quadratic formula or something, you end up with the square root of a negative. Up until today, we've always just said, well, no real solutions. Now today we'll add in some of the complex solutions, okay, some of the imaginary ones. And therefore, if I is defined as the square root of -1, then what does that mean I squared equals? Close. -1. If you just take and square both sides of the equation, you get I squared. You square the right-hand side, square root goes away, and you're left with -1. Okay? That concept is kind of just a fact that we're going to use going forward. Okay? We'll come back to that a little bit later on, but I wanted you to understand where it's coming from. If you take your definition of an imaginary unit and square both sides, you get I squared equal to -1. Okay? We're going to start by kind of going backwards a little bit, and we're just going to simplify some square roots. Okay? Now, ones that have negatives in them. So here's the idea. I'll give you the definition, and then we'll talk about just kind of working our way through it. Let's say that did not have a negative. Let's say it was just a square root of 50. How do I simplify a square root of 50? What would I do? What you're looking for is a perfect, hopefully the largest perfect square. That's a factor in this case of 50. Okay, largest perfect square because you're trying to take out any square roots that you can. Okay, so in this case, if I were to factor this, I could factor this into the square root of 25 times the square root of 2. And then I'm going to add one more thing. Square root of -1. So now if we go through and we take a look, square root of 25 is 5. Pull that out of the square root. There's nothing else I can do with the square root of 2, so I leave that alone. So if this was not a negative, there would be your answer. There's the simplified version of the square root of 50. And then because it is negative, you end up with an I. Yep. That's where the square root. So you end up with 5 square root of 2i. Okay. So I put the square root of -1 here on the first example because I wanted you to see where it was coming from. But realistically, as you move forward to kind of get to the point, you can always pull a negative outside of a square root as an I. Okay? Because you're taking the square root of -1 always is the idea. So therefore, if I factor the square root of -220 or 288, excuse me, what do I factor that to?
144.
Yep, 144 is the biggest perfect square that goes into that. That's a factor. So we could go square root of 144 times the square root of 2. And then again, we could write times the square root of -1, or realistically, you're just pulling the negative out of the square root with an I, as an I. And so, simplify, we end up with 12 square root of 2i. 12 square root of 2, the only difference is attaching the I because it's the square root of a negative. Let me stop for a second. Any questions on that at all? Yeah, so Tina?
Does it matter where you place the I?
I normally would put it at the end, and I'll show you why and just the reasoning in a second, because that's the way complex numbers are usually written. But the short answer is no, not really. I mean, you could put it with 12 if you wanted to. You could technically put it in the front if you wanted. It's all still the same. I usually just put it at the end. Yeah? It just can't be under the square root because the negative's coming outside of the square root as an I. That's the only place where it can't be, is under that square root. Okay? So here's the general rule, by the way. And especially as you work through this assignment, you're working with these things. If you can simplify first, you should. Then we're going to get into how do I add, subtract all these imaginary numbers, and operations working with them. Okay? But if you can simplify, that's usually a good place to start. Yeah, question now? Can you have a negative I? Yeah, you could. Not like if this 12 was negative or something, it's possible to have a negative. Yep. Which actually we'll take a look in just a second. All right, so let's get into complex numbers then. So if we now go from imaginary, this is the form for complex numbers, written as a plus bi. Okay? That's kind of your standard form of complex numbers. Which is the reason, by the way, when Sutita had asked, does it matter where the I goes? That's why I put the I at the end, so it kind of matches up in this form. Okay? Where A is a real number, and the bi is the imaginary part of your complex number. Okay? You're basically taking real numbers and imaginary numbers and putting them together. And those are called complex. What I will tell you is every number that is out there is a complex number. This is the biggest group of numbers that there is. Okay? Even something as simple as like the number 5. Number 5 is a complex number because I could write it as 5 plus 0i. Meaning I've got the real part and no imaginary part. Negative 3, same thing. I could write it as negative 3 plus 0i. Therefore, complex number. Okay? The next part you don't have to write it down, but I just want you to know where this is coming from. So here's the concept. Complex numbers are coming from combining real and imaginary numbers. Most of the time, everything we've done so far, and most of the time in this class, we're going to stay in the real numbers. But we'll do a little bit with complex and imaginary, this week in particular. All the real numbers are your rational, irrational, whole numbers, counting numbers, all that kind of stuff, all the numbers that we normally work with. So that's where complex comes from. It takes real and imaginary and puts them together. All right. So now, let's talk about, now that we have complex numbers, how do I work with them? That's kind of the main focus of today. How do I add them? How do I subtract them? How do I just do the basic operations with those things? Okay. So if we take a look, here's where we're headed. Basic operations, add, subtract, multiply, divide, when working with complex numbers. And we're going to put adding and subtracting together. I did not even give you an example because it's so straightforward, hopefully. In order to add or subtract, you're just combining like terms. That's all you're doing. Take the real parts and add them together. Take the imaginary parts. Just like you would, an I is just a variable. So add I's with I's. Add real numbers with real numbers. And we'll do that. We'll talk about that when we do the multiplying and stuff as well. That's the other reason why I didn't even put an example of this, because we'll include it in some other parts. Combine the real parts, combine the imaginary parts. Think about if you had 3 minus 5x and 7 plus 2x. You take the 3 and the 7, the constants, and put them together. You take the x's and put them together. That's all you're doing here. It's just they have i's instead of x's. That's the only difference. So there's adding and subtracting. Combine like terms. So now let's take a look at multiplying. Even multiplying you've done before with one exception that you have to remember and notice. Here's where that I squared equals negative 1 is coming back. Okay, we'll talk about that in a second. So remember, a complex number in the form a plus bi is just a binomial is all it is. And when you take one binomial times another, x plus 3 times x minus 5, something like that, all you're doing is foiling it out. You're just doing your distributing. Same thing when you're dealing with complex numbers. One thing you got to remember is at the end that I squared equals negative 1. That'll come back. Okay? So let me give you an example of actually multiplying these two things out. So here's two random complex numbers that we're going to multiply through and see what we get for an answer. 6 minus 2i times 2 minus 3i. So just like normal, let's FOIL, let's distribute. I'm going to take the 6, distribute that into the second parenthesis. 6 times 2 gives me 12. 6 times negative 3i gives me negative 18i. Then we move over and we distribute the negative 2i. We end up with a negative 4i and a positive 6i squared. So we've multiplied it out, and now just like if those were x's, we combine like terms. Two things you gotta keep in mind. One in particular. Remember, I squared equals negative 1. Therefore, this is not plus 6i squared. It's actually what? It's actually a minus 6. If you take the I squared out, put negative 1 in its spot, it's actually 6 times negative 1. So what you really have is this. And now, combine the real parts, combine the imaginary parts. 12 minus 6 gives you 6. Negative 18i and negative 4i gives you a negative 22i. And there's your answer right there. Okay. What I want you to see, and one of the things I want to just kind of point out here quickly is when multiplying two complex numbers, in this case, most of the time, you're going to get a complex number as an answer. Okay? You never want to leave I squareds in your answer. So if you see any I squareds, make sure you pull those out, change the sign, make sure you do a substitution and get those out of there. You should never have anything higher than an I. Okay? You shouldn't have I squareds, I cubes, that kind of stuff. So complex number times complex number, in this case, gave me a complex number. There are times, however, when you multiply these two together, you actually get a real answer. And here's what we're talking. Here's where we're going to talk about that. So last operation, the only thing we haven't talked about yet is division. When dividing, we're going to need to use what are called complex conjugates of each other. Everybody remember what a conjugate is? It's just the opposite, is all it is. So for example, if a plus bi is one complex number, then a minus bi would be the conjugate. Okay? It's the opposite sign of the imaginary part. A plus bi and a minus bi would be conjugates. So 2 plus 3i and 2 minus 3i are complex conjugates of each other. And the reason why this is a special case is because when you multiply something by its conjugate, you actually end up with a real number. Okay? When you multiply a complex number by its conjugate, you don't end up with a complex number like we just saw. You actually end up with a real number as an answer. And again, I'll give you an example of that as well. So let's say 4 plus 3i is my complex number. Therefore, what would the conjugate of that be? Negative 4 plus 3i, conjugate would be? Is it negative 4 minus 3i or is it 4 minus 3i? Which one?
Negative 4.
Negative 4. It's just the opposite of the complex part. That's why I asked that. Okay? So in this case, if we take negative 4 plus 3i, the number I gave you, and let's multiply that by its conjugate, negative 4 minus 3i. Just to confirm, I said you get a real number. Well, we talked about multiplying. Let's see what we end up with. And then we'll get into y, because I think the y, you'll understand that as well, if you actually recognize what we're doing here. So let's multiply this out. Let's distribute the negative 4. We get 16 plus 12i. Then we distribute the 3i. We get negative 12i and negative 9i squared. And And now we start to clean some stuff up a little bit. Again, let's get that I squared out of there. So what I really have is this is really just a plus 9 here at the end. Which, if you notice, positive 12i, negative 12i, those cancel out. 16 plus 9, there's the real number that we were talking about. We ended up with 25 as an answer. Now, here's the question that I have for you. And this is where it should make some sense if you understand what's actually going on here. Think back to factoring. If you have factors like that, what do we actually, when do you get a result where they're exactly the opposite of each other? Was it 80? This is just a difference of squares is all this is. So think about when you do a difference of squared, a squared minus b squared. There is no middle term, right? That's why the 12i and the negative 12i, the middle terms cancel out, because it's a difference of squares. Again, if you think about it, all that is one thing squared minus another thing squared. If I square negative 4, don't I get 16? If I square 3i, don't I get 9i squared? And there's your difference right there. That's all this is you're just multiplying out a difference of squares, which is why the imaginary stuff goes away, because the middle term cancels out and the I squared becomes negative 1. Okay, so if you're kind of understanding that, that's why we ended up with a real number rather than an imaginary number, okay, or a complex number. All right. Last concept then. Last slide already. Here's the last part of the lesson. I got 2 examples for you. When you are dividing complex numbers, you multiply both numerator and denominator by the conjugate of the denominator. And again, I'll explain why in a second. Whenever you divide complex numbers, you multiply by the conjugate of the denominator. So again, the reasoning behind this is if you remember back to Algebra 2, and you remember the idea of what was called rationalizing the denominator, anytime you had to get square roots, cubed roots, that kind of stuff, you can't have those radicals in the denominator. Remember, by definition, that's what an I is. It is a square root. So we're trying to get the i's out of the denominator, and this is the process we're going to use. This is the process that works out in that case. So if we take a look, let me give you an example. Like I said, I've got 2 examples for you. This one's actually probably the more difficult of the 2. And ultimately, I want to end up with an answer that no longer has an I in the denominator. That's the goal, is get that out of there. So what am I going to multiply this by then? We'll multiply by 1 plus 2i. And we do the same thing in the numerator, 1 plus 2i. Reason why we do the same thing in both spots, it's just a fancy way of multiplying by 1. If I multiplied by 3 over 3, that's 1. Well, when I multiply by 1 plus 2i over 1 plus 2i, I'm just multiplying by 1. It's just a fancy way of doing it. Okay? And now, we have 2 multiplication problems that we have to do. We got to FOIL out the top, FOIL out the bottom. See what we get. Okay? So if we take the 8 and I distribute that, we end up with 8 plus 16i. Then we take the negative 7i and distribute that. We end up with minus 7i minus 14i squared. Over, which we'll clean that up in a second. Distribute the 8, distribute the negative 7i. Same thing in the denominator. Distribute the 1. So I get 1 plus 2i. Then distribute the negative 2i. Negative 2i times 1 is negative 2i. Negative 2i times a positive 2i gives you a negative 4i squared. All right, let's clean this up just a little bit. If we go through, negative 14i squared is really just what? 14. Positive 14. Plus the 8 that's already there gives you 22. You've got 16i minus 7i. That gives you a positive 9i. Over The two i's cancel each other out again, as they should. When you multiply by the conjugate, the middle term should go away. And again, negative 4i squared is really just a plus 4. Plus the one that's already there, we end up with 5. And just a quick heads up when you check in answers today, almost positive that as you go through and you check your answer, they're going to give you this answer instead. They would write this as 22/5 plus 9/5 I. The reason why they're doing that is so that it's in a plus bi form. So it goes back to that complex number form. So it's not all over something, just splitting it up into two fractions. Okay? And as always, if you can reduce, you should. Okay? In this case, we can't, so we leave it alone. 22/5 plus 9/5 I. Notice, by the way, though, we did get the I out of the denominator. We ended up with just a 5. Okay? So that was the goal, was to get that I out of there. All right, let me give you one more. Last one that's actually a little bit simpler, but it's just a different version. This time, what do you think we should multiply by? Negative 2i. That would be the conjugate of positive 2i. Okay? So we're going to multiply by a negative 2i. This one, the reason I say this one is actually, I think, a little bit simpler is because I don't actually have to FOIL the whole thing out. I'm just distributing because I don't have a binomial. So when I distribute times the top, I get negative 16i. And then I end up with a negative 40i squared over negative 4i squared. So now, clean it up a little bit again. Negative 40i squared is really just positive 40. We still have the minus 16i. And in the denominator, negative 4i squared is really just 4. And once again, write it in complex number form. In this case, if I split this up, 40 divided by 4 gives you 10. Negative 16i divided by 4 gives you negative 4i. And there's your final answer right there. Okay. So this is just working with complex numbers. Simplifying them, adding them, subtracting them, multiplying. Just operations with complex numbers. Yeah, Aiden? If you're trying to write it in a plus bi form, then it should. Now, if you wrote this as, let's say like on the test, if you wrote this as negative 4i plus 10, same thing. I mean, I'm not going to mark it wrong because of that. But technically, a plus bi form, the real part comes first, the imaginary part comes second. Okay? All right. Here's your assignment for today. Biggest thing again that I can tell you, start off by simplifying any radicals if you can. Then do the multiplication, addition, all that kind of stuff. Then do the operations. Simplify first, though. Okay. Show your work so I can see your process, so I can see that you're understanding. Make sure you check your answers so you know if you're doing it right. Okay? Don't just copy the answers. Check them. Okay? Because otherwise, then if you're just copying, all you're doing is setting yourself up for a little bit of failure when you get to the test. Okay?